So we're here to learn Python programming, the speedrun edition. And I know you're probably looking at that title and probably wondering, this dork is not going to be able to show me how to program in Python, but I'm going to show you and I'm going to actually change your mind, my friend. Why am I able to speak to this, you might ask? Well, that's because I'm mostly a self-taught programmer myself, meaning that yes, I did complete a 4-year degree, but it was in information systems, which actually lacked the theoretical mathematics that would be needed for a computer science degree. So all that fundamental math stuff that comes with a CS degree, I had to pick that up on my own, literally as I was working. So I had to learn how to learn basically on my own. That's to say that most of what you see in terms of tutorials is just a lot of bloat that you won't actually use in your career, which then leads me to boil everything down to about 5 to 6 topics, maybe 7 if we're counting some bonus topics, that we actually need to learn programming in Python. So that's why for the next 30 minutes or so, we're going to go on a journey together as influenced by the 80-20 rule to understand programming in Python. And to do this, we're going to build a shopping list chatbot that we can interact with and add to a makeshift shopping list. So by the end of this video, you'll have a pretty cool chatbot to show off to your friends and actually take to the store with you if you want to understand what you need to buy before you actually go. Because believe it or not, I'm on a mission to help at least 100 million people.
Boy, that escalated quickly.
To change their lives through code and change it for the better, giving them access to what I would like to call the comic book life. And to aid in this effort, I've also created a downloadable cheat sheet, a Python Infinity Gauntlet, if you will.
I am inevitable.
That will help you go from point A to point B and be a reference, or hopefully will be a reference to you in the future, so that you can supplement and fast track your learning as much as possible. Programming doesn't have to be scary. I won't shy away from the fact that it's going to be challenging, but it doesn't have to be as scary as it looks. So first things first, what exactly is programming? This concept is a little bit misconstrued, so let's break this down piece by piece as slow as possible. And to help aid in this illustration, let's break this down using a illustration from a movie theater. So let's imagine that you're inside of the movie theater, ticket in hand, ready to have some well-deserved you time. To get to your seat though, you have to follow some well-defined instructions, basically starting with getting your ticket out, showing it to the person at the door, then heading to the theater that you're supposed to be in, which auditorium you're supposed to be in, I should say, then finding your row, then finding your seat, all inside of about 10 to 15 minutes, give or take if you went to the concession stand or not. But what you just did was follow a set of instructions to get from the door to your seat. And what that is basically like an algorithm or a way of communicating instructions so that you follow them every single time from start to finish, and they always are the same or correct, which is exactly what we do in programming, but instead we tell a computer to take these instructions and carry them out, simply because computers, literally by the given name, they're faster at computing things for us than we are as humans. And for the most part, they're a little bit nicer because you don't have to worry about them blowing up in your face directly in terms of arguments and all that kind of stuff. Now, in terms of your actual program blowing up, that's a totally different story. What if we get to the seat that we're supposed to be in, but someone's already sitting there? What if the seat is broken? What if the movie doesn't even play at all? These are also known as instructions, but known as edge case instructions because we necessarily weren't expecting them to happen in the given instructions that we had before. So with that in mind, that is now a condition or a conditional situation that we now have to come up with a solution for that we didn't already have in the beginning. Well, exactly how do we tell a computer what we need it to do? And I'm glad you asked. So here's how we do that, because we can't just plainly walk up to a motherboard and start speaking English to it, expecting it to actually give us a reasonable result. on the outside. Now with machine learning and AI, that's different, but again, can't just walk up to a bare metal machine and just start talking to it. It's not going to do anything for you. Instead, we have to use something known as a programming language to speak the computer's language. Okay, so now that we've got all of the theoretical stuff out of the way, let's get practical. And to do this, we're going to need what will be known as a code editor. I would highly suggest that everyone start what would be known as Visual Studio Code, pretty much the standard across the entirety of the community in terms of developer. And to get started even easier, I have a link down in the description that is going to allow you to get started really quickly without having to install much on your computer at all. But without further ado, let's hop into the computer and let's get started. Okay, so now that we are inside of the computer and we're going the more practical route in this case, let's start with the starting point that everyone goes with in terms of programming. In this case, that is starting with hello world. In Python, the way that we would do that would be print hello world. What did we just do? Or what does this mean? Basically, the way that this boils down is we say print, which tells Python that we want to send something from the parentheses down to the console, or what would be known as the terminal in other places as well. So here what we're saying, hey, Python, print whatever I tell you that I'm putting inside of these parentheses. Put it out there inside the world, and what I want you to say is hello world. So in order to run this, I'm going to go down into the console in Visual Studio Code. And by the way, I'm using a browser-based Visual Studio Code. That will be linked down in the description if you want to go ahead and follow along. But if I want to go ahead and run this, then the name of my folder, which in this case would be 30-minute Python /app.py. Assuming that I didn't fat finger anything like that, we should be good. Let's go ahead and run this. Go ahead and hit enter. And there we go. We get hello world printed out to the console. I'm going to throw some monkey wrenches in here just so you can see what would happen if there were some errors. So let's say, for example, you were setting this up and by just happenstance you hit a key and you hit space, for example. So let's say, for sake of example here, we have maybe we hit the tab button, for lack of a better example. That is automatically, or at least it should automatically give us a warning that something is already wrong. This is going, if I hover over here, it's going to tell me unexpected indent at Pylance. Inside of this is basically saying, hey, you can't run this, you cannot run this program at all. And even if I go ahead and try and do the same thing like I had before, and to do what I just did inside of the programming area down here, to do that again, if I want to run the exact same command, I just go ahead and hit up and then hit enter again. That then will tell me, whoops, something is wrong. Danger, Will Robin. So what do we need to fix? What we need to fix is the fact that we now have indentation that we should not have. So in Python, everything that we do is indented, or in terms of code block, everything in terms of code blocks is indented. So what that means then is if we indent something that should not be indented, then the interpreter is going to scream at it. It is right here. And most of the time, the errors that you will get will be somewhat helpful. In this case, this is telling us an indentation error, so we know exactly where to look. So we know, hey, we may have some indentation that should not be there. So that's the first flag. And then again, it tells us unexpected indent. So again, that's the solidifying or the culmination of, hey, there's an indentation that should not be. So in order to fix that, obviously we can just go ahead and hit backspace, save the file, and we're good. But what if we just hit space by accident? Now we get a different error similar to it, but slightly different, because again, there's not as much space, but it still is some indentation that the interpreter is picking up. So again, even if it's just that little space right there, if we go ahead and run this again, it's going to give me exactly the same thing. So all that to say, understand that your print, or more specifically your indentation, matters inside of Python. So now let's go ahead and clean this up. I'm going to go ahead and clear the console so that we're not looking at a whole bunch of errors going forward. So to do that, I'm just going to say clear, and that's just literally clear in Linux and in Mac machines, you can do that with no problem. In a Windows machine, you have to use a different command that will be CLS. But if you're using the exact same thing that I'm using here, it should be exactly the same. So go ahead and hit clear. That will clear the entire console for us. Now, what we want to talk about further will be what the heck this print thing does and how does it all work and all that kind of stuff. So if you hover over print, what you're going to see is the definition of how the print function actually works. And you also see some documentation on that as well. That's basically as if we were calling the help function inside of Python. So just for sake of example here, if I say help and then print inside of it, what I would expect to see, in assuming that I don't need to print that further, I don't think I do, but let's see. If I go ahead and there we go. So we get the help on built-in function, print module built-ins. All that's not really relevant at the moment in terms of understanding what all of that does, but just know that what the print function is supposed to do is take some values and then print them out to the console. Thing that you really want to understand with functions in general is that what they do for us is place a bunch of code inside of one area so that we can basically put a name on it or slap a label onto it. Then when we need that thing again, we can pick it up and go and use it. So for a better example, say that you were moving from one apartment to another and you wanted to take your kitchen supplies from your current apartment to the next apartment. What you would do would be place everything inside of a box, place a label on it, call it kitchen supply. When you get to the new apartment, you take it out of the moving truck, put it directly into the kitchen, and you know exactly what it's supposed to be. So you know everything that's supposed to go in there is good for the kitchen. You know what to do with it, you know how to use it. That's exactly the same thing that we would do with a function here inside of programming. Okay, so I've been talking a lot about this whole help function, but we can do a lot more in terms of Python and printing and all kinds of things here. So we can also print out advanced calculation that we can then run this the way that we did before. So in this case, we'll say Python 30-minute Python app.py again, and we should get hello world and 13, exactly what we were expecting from before. So what if we then want to do some more stuff inside of this file? So we can just copy this and bring it down here a couple times, maybe change a couple numbers here and there. So 1 and 5 here. Cool. So if we go ahead and save that, we get some more numbers. 10 and 14. We can do a bunch of different things here, but the more powerful thing in terms of these numbers and strings and words and stuff like that would be to make them more reusable inside of our code. And that's the normal thing, or the thing try to adhere to in terms of programming. Dry, don't repeat yourself as much as possible. So when we can, what we want to do is place this, maybe this 4 plus 9 inside of a variable called, let's call it calculate, set equal to 4 plus, and then instead of 4 plus 9, we can just copy this and place it down here. There we go. And what we can do from here is again go ahead and run this like we were expecting before. 13, 10, and 14, similar to the first results that we had from before. So that means so now, given the fact that we can place numbers inside of a variable, we can also place strings and other types inside of variables as well. So in this case, let's go ahead and create some more variables. Call this first one hello. By the way, if you were looking at what I just did and wondering how the heck did you do that, just highlight everything and then hit the double quotes or single quotes, doesn't matter. It'll do the same thing, but that's best literally just how I did that. From there, we're going to go ahead and print these out, or we could if we wanted to, but I'm going to add some more values here. So let's say light equal to true. So this is an example of a Boolean value that we haven't yet talked. So in everything that we've done so far, we've always had some type of real life value in terms of a number or a word that we can look at and see. But this is actually a true, on, or false, off value. What this allows us to do is place inside of our programs a way to turn something on or off, or make it true or false. In terms of variables themselves, what they all do is basically store values inside of themselves or inside of memory in the computer, as it were, and then allow us to, again, go and retrieve that value. So if we were going to say lights in this case, or in this example, let's say we were going to use this so when we come into a room, turn on the light, we turn on the lights, and when we leave a room, we turn them off. Okay, so to make this a little easier to see and to clean things up just a little bit, I'm going to delete everything that we've been talking about so far. But if you need to keep this around, feel free to keep it inside of a comment. I'm just going to do it for the sake of actually making it look pretty on the video so it's easier for you to follow. Only thing next that we need to talk about will be how we would break or bring two words. In this case, let's say we had hello and world and there were no spaces in between them. We wanted to just sandwich them together. How would we do that inside of our program? We'll say first we'll do, and we're going to then add the plus sign, Jones. Okay, so what is that going to do? Well, what that's going to say to the Python interpreter is, hey, this value over here on the left side is a string, and then this value on the right side is also a string. So what we can do now is combine both of them together and make a new string. So loop over all of them and then combine them all together. If we go ahead and save that, what if we now want to add a space inside of that? Well, again, what we would need to do is add another string in the middle of this, and that would then be space. And then again, we do plus sign, another concatenation, and we then get a space in between Mike Jones. So before we didn't have one. Now run this again, we get Mike space Jones. What if we tried to do a print of a number and let's say Jones? Well, pause this for a second and answer this for me, for you, for both of us at the same time. What do you think is going to happen here? Now, if you pause the video and took the time to actually think about what happens here, you would probably already see that that's going to give us an error. The reason why is because Python is not going to understand exactly what this is going to mean to the interpreter. So if we go ahead and run this, again, we should get a type error. And that's a different type of error that we didn't see before. Before we saw an indentation error, but this time we get a type error. So what this is saying is unsupported, so type error, unsupported operand, basically have tried two different data types. And by the way, if we want to find out what data types we are actually using, we can use the type value in this case. I'm just going to comment this out so you can see this really quick. And we'll say print, and I'll place type and 9 here. And then I'll do print and type of Jones here. Okay, so we'll save that. I'll go ahead and clear this because you won't be able to see it if I don't. All before now have class int class string. Now the class thing, don't worry yourself about that, what that actually means right now. That's a little bit further ahead. The thing that we want to point out specifically here is all that we want to know is what type of data are we working, integer or float or what have you. This is telling us, hey, you're working with a integer in Jones or in 9 and a string in Jones. Cool. Now that we know that, what do we get the chance to do? Well, in certain situations, we can use method, or we can do things like concatenation if we're working with string, or if we're working with two different numbers, we can put those together. Have to be playing in the same ballpark or same field in terms of bringing things together or using what would be called methods inside of a object as well. So with strings, we can also do, let's say, lower instead of uppercase Jones. And if I go ahead and run that again, or instead, I'll keep that and let's do this instead. Let's go back and let's say print of Jones, and then I'll do dot lower. So now you can see that I started with a capital J before, but when I get my value, it doesn't have the capital J at all. It's just the value of lowercase j instead. That is because of the method that I chained at the end of this object, in this case, a string. That is only available to me because I'm using a string. And there's a whole list of documentation on that. I'll leave the documentation link in the description. But that's basically the reason why I can do the things that I'm doing here, is because this whole class thing, that has inside of it functions that I can then go and use in terms of string. Because I'm using a class string, I have access to a function or method called lower. So that's the whole kit and caboodle, how methods and all that kind of stuff work. Okay, next up would be compound data types, and that is a way of placing two different data types on top of each other, as the name suggests. But what we're doing here is placing, or at least we have access to, list objects and also tuple. But you'll see mostly use lists, objects, and things of that nature. So for the sake of example, let's say we want a list to be produced here, and we'll say list of numbers of 1, 2, 3, 4, 5, 6, and 7. And then we'll create an object to go along with this. So this will say name, and Mike is going to have an age of 25. Mike. Guess what day it is? Anyway, we can also then create a tuple. So we'll say tup is going to be equal to, and the way that we create those would be with parentheses, and then inside of this we can place a value. Take a look at what we have. In this case, we have a list, also have a list of values in terms of strings or floats or what have you. We can also then have an object that can hold different types of values as well, and an object is known as a key value pair. So the way that we get access to the values inside of the memory locations inside of our computer is by giving the particular key that we want to go and access, and then inside of that key in the memory location, we then grab the value that is then placed in it. So from here, we could say if we wanted to gain access to this value, what we would then do is say we want to print LST at index 0. So that would give us the first value, which in this case is 1. If I wanted to get access to my object or the value inside of my object, let's say the name, I would say print and then obj, or I could then say name. So this should give me both 1 and Mike in this case. So if I go ahead and run this, I get 1 and Mike. Cool. So if we want to gain access to these values, then what we would need to do is then print them out. And then what we would say is LST at index 0, because we start counting in computer science at 0. And then in this case, for our object, we would say obj, and then give the name or the key that we want to gain access to inside of our object. So then if we want to gain access to the values inside of our tuple, it's the same thing that we would do in terms of indexing for the list, which would be tup set equal to, not set equal to, print. We want that to be tup and bracket 0 as well, and that is going to give 1 mic 6. So here we go. In compound data types, in this case, data types like lists, objects, and tuples. And again, we also have access to other types, but this is the gist of what we need to know in this case for today's example. So remember that example that I mentioned earlier in the video in terms of the broken seat in the theater. Now we're going to double back to that example, check that out in terms of how we would do that or produce that inside of code. So to make things a little bit easier, again, I'm going to clean slate this whole thing again, and we'll say clear. From here, what we're going to do is create a broken chair. So we'll say chair is equal to broken, and this is going to then get placed inside of a if condition or an if state. So from the statement that we made earlier, if the chair was broken, we needed to figure out how to handle that type of situation. How would we handle it? Well, maybe if the chair is broken, we leave, or we ask for a refund, or we just don't come back at all. So let's figure out how we would do that. So in Python, what we would want to say is if the chair is equal to broken, then if this is true, then we want to ask the customer, hey, what do you want to do? So we'll ask for some input here. And this is a way to get some feedback or values from the outside world into our program. So we'll say, would you like a refund? Okay. Then from here, or let's just do this as a full refund. You know what? Let's make it an object. Let's make it an object, and let's say full refund is going to be equal to 20 bucks. Cool. Let's say that the movie cost 20 bucks. Very expensive movie probably, but and things are rising up. Anyway, if that is not the case though, so if the chair is not broken, so elif chair is not equal to broken, then what we would do is ask the customer, or ask, is someone sitting there? And if ask is equal to no, then just say sit down, right? And if none of that, if everything goes well, we should have a chair to sit down inside of. And if there is no chair, we should refund. But if there's no chair at all, then we should then default to movie is not playing. There is no chair to sit inside. From here, let's go and run this and see what we get. If we go down to our terminal here and we go back and run this here, we should say, hey, do you want to refund? Because the chair, as we said before, is broken. So in this case, we'll say no, and I'll just go straight to the end. And if I really want to see what that actually becomes, I should probably print this out. So let's print out refund just to see that that gets printed out. And then we'll run this again. Full refund, 20 bucks. Awesome. Cool. So this would be a type of scenario that we could see at the end of a transaction inside of a movie theater for a refund because the seat is now broken. But what happens if we change this from broken to something else? So let's say working. So if it's not equal to broken, so that means we should get that. From here, we go ahead and run this again. Oops. I don't have availability to have you guys see that. So let me clear this out a little bit. Run this again. This time what we were looking for, because working is the value that we have inside of chair and is not equal to broken, that now means that we ask the customer, hey, is someone sitting there? No, then just say sit down. So we'll say no, sit down. Cool. Okay, so I've been rambling a lot and I am slightly over time, so let's speed run this a little bit. So from here, what I do next is talk about two more things, or that would be functions and loops. And then we're going to build our chatbot for the store. So let's go ahead and push. Okay, so function, like I mentioned earlier in the video, a function is a way to encapsulate or bring together some sort of code. So in Python, the way that we do that is by asking or giving something a particular name, and we'll say ask name in this case, and we'll leave the parentheses empty for now, and we'll then say first name is going to be equal to input. We'll do what is your first name. And then we'll also add at the end of this guy, because what happens inside of the input function is it returns back to us a string. So because we know that, we can also do capitalize to the end of this as well. And that's going to place a capital letter on the first letter inside of our name. So then we could either do print, or later on we'll talk about return inside of a function as well. So we'll say, let's go ahead and save this, run it down here. And so you'll see, well, let me go ahead and say no. And you'll see that we just get sit down and then nothing else happens. So the if statement runs and we answer all the questions and all that kind of stuff. But then we get to our function and then nothing happens. But we can see that we have a print statement that's supposed to do something. Why didn't it do it? Well, the reason why it didn't is because we didn't call the value or the function name inside of memory. So again, everything inside of our program all have to live somewhere inside of memory. Everything inside of a computer is placed inside of memory, or the RAM inside of your computer, so that we can easily access it. When we access that information, is we call the value, or in this case, the function name. So we'll say ask name. And then in this particular situation, if I go back here, I'll clear this to make sure we can see it. If I go back and run this, I'll go ahead and hit again, what is your first name? Okay. So we'll say Joel. So I'll go lowercase in this case for example purposes, so that you can see that is going to be, you can't see me pointing at it. You can see that this J here is going to be upper. Go ahead and hit enter. That then is going to give me Joel, Joel, uppercase in this particular situation. I'm going to bring this if statement, curtail this a little bit so that it's not as verbose, but you get the point. In this particular situation, now we have grab the function and go ahead and use it. But what if we wanted to add something inside of this? In this case, let's say a parameter. Let's, for the sake of example, call it last name. So in this case, now if I go ahead and it's going to give me an error. The reason why is because I am now asking for something that I'm not giving to the actual function, which in this case is last name. So if I go ahead and say last name Jones, again, I will need to clear everything so you guys can see that. And if I go ahead and run this, and I'll do up arrow in Python, again, what is my first name? Joel. All right, cool. So we get Jones, and everything is working. Don't actually see Jones because I didn't print it out. Go ahead and print this out. We'll say last name, and then I'll go ahead and print this out one more time. And then this time we'll get Joel Jones. This time we have what we're from our parameter, but we saw earlier in the video, give that default value as well. So I'll leave some more documentation down in the description, and also in the cheat sheet that I'm going to also leave down in the description below. That will have everything that you need to know in terms of what those parameters will look like. But for the gist and purposes of this particular video, because we're under the time crunch, we're already over it. Because of this particular situation, the parameters, and there are actually 4 different ones, again, linked down in the description for what that looks like. That is all inside of one single function, or it can be for a one particular function. And this function parameters per se right now is known as a positional argument. So the only reason that this actually works is because we gave the parameter, in this case last name, to the function so that it actually knows what it's supposed to go and do. So the last thing that we need to talk about theoretically in terms of the fundamental building blocks that we need for programming in general would be loops, and that is going to be for loops and while loops. So for a perfect example on how that would look, I'm going to also take this function call out, and we'll create new set of a new list called fruits, and we'll place apples inside of that. Banana, B-A-N-A-N-A, pear, and watermelon. All right. So let's say I wanted to loop through all of these values here and print them all out. The way that I would do that would be with a for loop, and to denote that I want to loop through everything, I'll say for, in this case I, or the example placeholder is going to be called I. Then I'll say in fruits, and we will then print I from here. And we can also get the same similar situation out of a while loop as well. So the way that we would do that inside of a while loop would be in this. First, we would have to initialize an index or indexable variable for us to go through. So we would say index first, in this case of 0. Then we'll say while index is less than the length of our fruits list. What we then want to do is get access to the current fruit. So we'll say current fruit, if I could spell fruit, equals fruits at index. We will then print our current fruit. And set our index up by 1. So plus equals 1. So again, if we go ahead and run this guy, we should get the exact same thing. So banana, pear, watermelon, apples, banana, pear, watermelon as again. So now that we have a good understanding of the building blocks inside of Python, let's go ahead and build out the full program that I promised you guys at the beginning of this video, which at the end, what you should have the ability to do is build your own shopping list maker or bot, trivial as it might be, but it may actually save you some time to get some shopping done for your grocery list for this week. I'm rambling. Let's get in. Okay, so to make this a little bit easier, I'm going to make a different file, and I'm just going to call it shopping bot. So let's now build our handy dandy shopping bot now, shall we? Okay, so what we need first is, in terms of what we want our program to do, is ask for the name of the person. So we'll say ask name is going to be equal to, or have no parameters inside of it, and we'll say name equal to input of what is your name. And that is going to take capitalization. So we'll say capitalize. And again, if I hover over this capitalized value, you can see the documentation that goes along with it. So inside of this, what we're doing or taking into consideration is the fact that we're using a string, and then we have access to this method that we talked about earlier. So from here, we'll say that we want to return name at this point as well, and we'll say def add to cart is going to be equal to, or have inside of it, an item and shopping items. So we'll take in the actual item and how many values we actually need, and we'll say shopping shopping items dot append, and we'll return shopping items. Cool. We'll then say remove from cart item shopping items. Shopping items. Item or if item in shopping items. We want to then remove shopping items, or that item from the list, I should say. And then we'll just print that. So we're going to place this inside of an F string in this case. And F, let's do F item. Removed from cart, or from your cart. Cool. If that is not the case though, then we want to just print out and say an F string of you don't, let's just escape that really quick, so don't have that particular item in your cart. Okay. Okay. So let's break this down a little bit so we're not going too fast. So if the item is inside of the shopping items list that we're going to have, then we're going to look for that value inside of the list. So that's what this remove function does. We're going to look inside of it, and if we find it, then we're going to remove it from the actual value. This isn't going to give us anything just yet. It's just going to say function for now because we don't know what shopping items actually is. It's just denoted as any right now. But when we give it a value, revisit this, and you'll see that this is going to change from just a function to actually showing documentation later on. Here we're just going to show the values that will say show items of shopping items, shopping items. Yep, there we go. Oh, and before I forget, let me also go back up to the remove and return the shopping item so we can actually have access to that. Then we'll go ahead and iterate over the list of items to show them. And what we will do will be if not shopping item. So if it's not the list, if we don't have a list of items, then we'll say that we are empty, or that our cart is empty. Your cart is empty. Otherwise, else, we will say print my shopping list has, and then we'll print out what it actually has. So we'll say for I in shopping list, if I could spell shopping list, or shopping items, I should say, print an F string, which is going to have a couple of spaces, dash, and then the I, so we can actually see what's in there. That is then going to give me, or from here, we'll create the actual function that's going to get ran at the end here. So we'll say main of shopping items is going to be equal to an empty list. Name, we're going to then ask for the name, so ask name here. And then we'll print an F string hello name. All right, so while true, so while this continues to run, we're going to ask for a command, set that equal to the input of which command would you like to do. And our options are going to be add, remove, show. That's all what I had in my notes. Let me just double check. And exit. Oh, sorry about that. So we gotta be able to get out of here. So if we now have our command, we then again are going to do some if, or checking to see what's inside of that command. So we'll say if command is equal to add, then what we want to do is set a number of item and set that equal to int input because we need to do something called casting inside of this input, because what it gives us back is a string. So what we'll say is, how many items do you need? And we'll then say for some value or a number or a placeholder that we're going to have here. So we'll do for placeholder in range of num item. Item is going to be equal to input. What item are you looking for? And we'll then place that item inside of our shopping items value to add, and that is going to take in our item and the shopping items value here. If that is not the case, or elif, add is not the command that we're looking for, so elif command is equal to remove, then what we want to do then is say item input and what are you removing, which then we want to tell shopping items what to remove. So we'll say shopping items remove from cart, item, shopping items. And we can do this because we are returning the item back into the function. So that's going to give us access to the value that's inside of that particular variable inside of that function. So then we can do an elif again and say if command is equal to show, then what we want to do then is item equal to input. Oops, sorry, not input. I don't want to input anything. I just want to show it. So I just want to show item and call what's inside of show item. Saying if the command is show, then what we want to do next is just show the values there. And if nothing else, or if this is not the case, if show, remove, or add are not the values that are inside of command, what we now want to do is just say that we want to exit. And if that is the case, then we would just say print goodbye, and that's it. That would be pretty much it. That's it, guys. And pretty much what we need to do from there is just break out of here, and we would then, let's do else. Yeah, have a base case of print invalid command, please try again. And assuming that everything works out correctly, we should be able to grab the name dunder equal to dunder main, and we should then be able to run our main program. So assuming that I didn't fat finger anything, what we should be able to do here is go down to Python, down to our console, and run Python 30-minute what did I call this, shopping bot. And here we go. We got our name. So we got the prompt for our name. So I'm asking for my name here. Hello, Joel. What would you like to do? I'll say add. And how many items do you need? Let's say 4. I'll do bread, milk, cheese, and water. And what I want to do now, let's show the items that are in here, which are in this case would be bread, milk, cheese, and water. Let's then remove a value, and I'm going to remove cheese, and it says that everything is removed. Let's make sure that is actually the case. Let's now show what we have, and you guys can't see that right now, but what should be showing up here, I'm just going to move. Here we go. What you should be able to see now is bread, milk, and water. That's what we are expecting to see. And last but not least, let's go ahead and exit to see what happens now. Goodbye. We are done. We completely now have a fully working chatbot to build a shopping list, go to the store with if we wanted to before we go to the store, obviously. But the gist of this is basically done. To make things a little bit more clearer and to make things easier to understand, let's walk through, if you need to, one more. What this while loop actually does is while something is completely true, or while till we break out of this loop, what we're saying and what we want to do here is we want to continue on through this loop many times as we can till we actually say we want to exit. So until we say exit, and basically until we say break at the end of this, this is going to continue to run. And is going to continue to ask for this command over and over and over again. The thing that you want to get tripped up is, or tripped up on, is one, this area right here is basically going to grab a string. So how many items do we need? We're expecting that to be value of a number in string format. So because of that, we're going to then pass that value that comes back from input inside of int, and then change it from a string to an integer. Or if we were doing this as a float, it would be string to float or what have you. But that's basically the gist of everything that we have for now. And then this guy right here is more or less just a way of telling a for loop or a Python for loop to hold a place for this to iterate over and over and over again until we end the loop, basically. So all that to say, that is basically the gist of what we need to know. Again, I told you Python is not as scary as it looks, or programming itself, not as scary as it looks. It is slightly difficult in time. It is not as scary as it looks. Hopefully this video has made you a believer that you can become a programmer if you put your mind to it. And if no one has told you today, I believe in you. So please believe in yourself. And until next time, blurt out.